There is no iron in a drum of iron phosphate solution. In an iron phosphate conversion coating process, ferrous surfaces such as steel and iron are converted to iron phosphate, and aluminum and galvanized surfaces are etched to increase surface area for mechanical physical paint bond. The parts to be treated are bathed in or sprayed with an acidic solution. This solution reacts with the iron substrate of the part to be treated and dissolves the iron from the part. This process is commonly called pickling. The iron consumes acid and is dissolved, yielding hydrogen gas. The reduction of hydrogen ions at the surface causes a localized increase in pH. As pH increases, the dissolved iron will combine with the phosphate in solution and precipitate and redeposit on the part. pH control is critical. At pH below 3.5, the part will pickle, but precipitation will not occur. At pH above 6, the part will not pickle. As the iron phosphate layer builds on the part, less iron is available for dissolution. Thus, the iron phosphate coating is self-limiting. Accelerators are used to speed up coating formation. In addition to speeding the process, some accelerators add coloration to the coating. This coloration can be considered a benefit in some applications, but can also cause paint problems. Oxidizers are also added to formulas to promote removal of iron from the metal substrate. These oxidizers include bromates, nitrites, and chlorates. Use of oxidizers provides a heavier coating weight and a more uniform coating. They are not compatible with detergents in their concentrated form and require careful bath control since they are extremely aggressive at low pH. Iron phosphatizing causes hydrogen gas to escape from the metal surface. The deposited conversion coating has pores, which are the vents through which the hydrogen has escaped. These vents are chinks in the armor of the corrosion protection provided by the conversion coating. The function of a final seal is to plug up these openings, effectively forming a barrier to corrosive agents, while promoting adhesion of organic coatings. The most effective final seals are chromate seals. Chromate seals are a mixture of hexavalent and trivalent chromium, which deposits a barrier of mineral-like salts in the pores. This effectively plugs the pores and occludes water and oxygen, two prerequisites for corrosion. The deposited salts provide galvanic protection to the steel underneath. Three-stage washer systems are typically used in high-volume conversion coating applications. As shown here, the system includes temperature control, metering pumps for concentration control, and a conveyor on which the parts travel that controls exposure time. Impingement depends on the proper location, alignment, and operability of the spray nozzles, and on the spray pressure, which can be a controllable variable of this system. In the first stage, a detergent iron phosphate will be applied. This will be followed by the water rinse and final seal. As shown in this animation, this type of system is well suited for large parts and high-volume applications. Spray or steam wand application systems are typically used in low-volume job shop applications, or where the part to be coated is very large. The equipment allows for temperature and concentration control, but time and impingement are controlled by the operator. They do offer the operator the ability to get to and treat hard-to-reach recesses. On the downside, inattentive operation can result in uneven coatings, missed areas, or excessive use of product. Fluctuations in bath concentration can cause changes in the coating. Concentration must be closely monitored. Fluctuations in concentration can cause flash rusting, streaky coatings, over or under phosphatized parts, and pitting. The best method of monitoring bath concentration and acid consumed levels in the field is titration. The burette method is the most precise and therefore recommended. Glassware should be cleaned and rinsed with DI water before titrations are performed. The chloride level in a phosphate bath is often overlooked. When a bath's chloride level gets too high, typically above 100 parts per million, corrosion can occur. This genie cannot be put back in the bottle. No rust preventative or additive will prevent corrosion from occurring once the chloride levels are too high. There is no alternative but to dump the bath. The tank should then be rinsed to remove any excess chloride. The rinse tanks should be dumped as well.